Hi, and welcome to the Machine Ethics Podcast. This month, episode 51, recorded in early January, we're talking to Rob Miles, a communicator of science, machine learning, computing, and AI alignment. We chat about why we would even want general artificial intelligence, general AI as narrow AI where its inputs is the world, making predictions that sound like science fiction. We elucidate terms like AI safety, the control problem, AI alignment, and the specification problem, the lack of people working in AI alignment, the fact that AGI doesn't need to be conscious, and how not to make a AGI. If you'd like to find more episodes like this, go to machine-ethics.net, or you can contact us at hello@machine-ethics.net. You can follow us on Twitter, machine_ethics, on Instagram, Machine Ethics Podcast, and you can support the podcast on patreon.com/machine ethics. Thanks again for listening and hope you enjoy. Hi Rob, thanks for joining me on the podcast. It's really great to have you. And if you could just give yourself a quick introduction, who you are and what do you do?
Oh, yeah, okay. My name is Rob Miles. I am, I guess, a science communicator, popularizer, I don't know. I spend my time explaining AI safety and AI alignment on the internet, mostly on YouTube. I also now run a little podcast, which is just an audio version of a newsletter run by Rohin Shah, the alignment newsletter, which summarizes the week's research in AI safety. But most of my time is spent on the YouTube channel, which is aimed a bit more at the general public.
Awesome. Thanks very much. So the first question we have on the podcast generally is a quite open-ended one. What is AI?
What is AI? So I would say AI is, it's a moving target. I think it's I have a video where I talk about this question actually. I think it's like technology. If somebody says, I'm not good with technology, they're probably not talking about like a bicycle or a pair of scissors or something, right? These are all technology. But once something really works reliably and becomes a deeply ingrained part of our life that we kind of don't think about, we stop calling it technology. We reserve technology as a word for like stuff that's kind of on the edge, stuff that is still not actually very good, stuff that's not reliable, stuff that often breaks and we have to think about the fact that it's technology, or stuff that we don't really understand very well yet. These are the things that get labeled, generally speaking. So it's like mostly electronics at this point. And I think AI is a bit like that as well. AI is things that computers can do that they didn't used to be able to do. Like there was a time when like figuring out a good way to schedule the flights for your airline to make sure that all the pilots and planes got to where they needed to be logistically, when that was like artificial intelligence, right? And we wouldn't call it that these days, I don't think, because it's the technology is many decades old now and it works quite well. But if you were to try and do that with a neural network, then we call that AI again, because it's kind of buggy and unreliable and new. So yeah, I think the origin of the term artificial intelligence is, it's a bit like the difference also between a robot and a machine, right? A robot is a machine that's designed to do something that a person does. And once we stop thinking that this is a task for a person to do, we tend to stop calling things robots in the same way. Like it's not like a robot crop harvesting. It's like it's a combine harvester. It's just a machine at that point. And so yeah, I think AI is about getting computers to do things which we previously thought were the domain of human minds.
Yeah, like science education.
Right. Yeah, sure. If you could get a computer to do that, that's for sure AI.
Yep, exactly. Cool. So with that kind of foundation, somewhat, we have these kind of terms that we throw away, and I'm kind of trying to get us to the point where we can talk about AI safety stuff.
Okay.
So we have this idea that we have machine learning techniques and kind of old school AI, like you're saying, like different techniques which have become just part of our world now, essentially. And some of those things we kind of categorize as kind of simple AI or constrained AI or AI that is just good at one thing, right?
Mm-hmm.
And then we have this more broad idea about kind of general AI or super intelligence or these kind of artificial intelligences, which are maybe programs that can do more than one thing or can learn kind of a broad range of stuff that
Yeah.
they can do. So I guess the question is, why would we want that? Is an interesting question to answer before we then dive into kind of what can go wrong. So when we're talking about superintelligence, general AI, why would we want to do this?
Yeah. So yeah, there is this very important distinction between what I would call narrow AI and what I would call general AI. Although it's not really a distinction so much as a spectrum. There's a question of how wide a range of domains can something act in. So like, yeah, you take something like Stockfish is a narrow AI. Its only domain is chess. All it can do is play chess. It plays it very well. But then you could take something like AlphaZero, which is one algorithm that can be trained just as well to play chess or Go or Shogi. And so that's more general, right? And then, and now there's MuZero, which is even more general than that because it plays chess, Go, Shogi, and also Atari games to a superhuman standard. So, so why do we want generality? Because there are a lot of tasks that we want done in the world which require generality. Like you could also think of a general AI system as being a narrow AI system whose domain of mastery is physical reality, is the world. And that's just a very, very complex domain. And therefore that's like, the broader the domain, the more general the system is. So I sometimes talk to people who say that AGI is impossible. And there's a sense in which that is actually true, in that perfect generality is not possible because that would have to work in every possible environment. And, well, there's infinite possible environments. So like, for example, one environment is a kind of maximum entropy environment where it's just complete chaos. There's no structure to the universe, and therefore you can't achieve anything because there's no correlation between the things you do and the outcomes that happen. But if you consider only our universe, it is very optimizable. It's very amenable to agency. It is actually, like, as far as we can tell, it probably runs on fairly straightforward mathematics. It's probably fairly low complexity, in the sense of like Kolmogorov complexity or something like that. It's quite structured. It's quite regular. It has causality. Induction works quite well. So you don't actually need to create a fully general agent. You just need to create an agent which is able to act well in our universe. And that is general. Like, that's general enough for what we need, which is an agent that's going to do things in the real world. The reason that we want that is because there are a lot of tasks that need that level of generality. If you want an agent to run your company, that just is like fundamentally a very broad thing to do. You need to be able to read and understand all different kinds of information. You need to be able to build detailed models of the world. You need to be able to think about human behavior and make predictions. And like, it would be pretty difficult to train something that was a really effective CEO, perhaps a superhuman CEO, without it also having all of the other capabilities that humans have. You would expect there's a chance that there's kind of a threshold that gets passed. I don't know if this is true. This is speculative, but like, for example, if you have a very simple programming language and you start adding features to it, you, past a certain point, you hit a point where your programming language is able to express any program that can be expressed in any programming language, right? You hit Turing completeness, that there's like, once you have a certain level of capability, you in principle have everything. Maybe not quickly, maybe not effectively, but like you've created a general purpose programming language. And it's possible that you get a similar effect. I don't know if this is true, but that the easiest way to make something that can do almost everything is to just make something that can do everything.
Right. And I guess the practical use of everything in that sense is that we have something that we can deep mind sort of way, we can solve big problems, right? So we can solve get rid of diseases, we can cure aging,
right.
We can avert disasters, all that sort of thing.
Right. If you have a very powerful system that's able to, if you have a general intelligence that's able to act in the real world, then in principle you can set whatever types of goals you want and expect to get solutions to them if solutions, exist or can be found. And that's kind of the end game, right?
And that's like, I mean, I want to say science fiction, but that's what we're moving towards, right? That's what people are trying to research and create is this more generalized idea with this kind of really quite powerful idea behind it that we can solve or get answers for some of these problems.
Yeah, it's a pretty utopian ideal. But the thing is, I want to address the science fiction thing because it's something that I often come up against, which is, I think I'm trying to formally express what the mistake is, and I'm not going to. But I think it's related to like confusing A implies B with B implies A, possibly, which is to say, most science fiction predictions about the future don't come true, but nonetheless, every significant prediction about the future that has come true has sounded like science fiction, because you're talking about technology that doesn't exist yet, right? You're speculating about how things might be drastically different because of the effects of technology. That's going to sound like science fiction. And so the fact that it sounds like science fiction doesn't make it less likely to be true, unfortunately. Like, it would be convenient if you could evaluate the truth of a complex claim by categorizing it into a literary genre, but it's not that easy. You have to actually think about the claim itself and the world and the technology and like just run it through and think about what's likely to happen, because whatever actually does happen, we can be confident would seem like science fiction from our perspective.
And definitely as it's happening as well, like in hindsight, it probably feels less like science fiction because it's normalized. But
yeah. I mean, can you imagine going to someone, 50 or 100 years ago and say, hey, so these things that we just have these like adding machines, these computers, they're going to get way, way better. And it's going to be, everyone is going to have one 1,000,000 times more powerful than all of the compute on Earth right now in their pocket. And they're all going to be able to talk to each other at insane speeds all the time. And like, or you know what, maybe don't give the context. Maybe just say, hey, in the future, basically everyone on Earth is going to have access to like infinite free pornography. And then just see how likely does that sound? That doesn't sound likely. It turns out it's one of the things that happened.
Yeah.
The future is definitely going to be weird. And so like there's no way to get around just really trying to figure out what would happen. And if what your best guess of what would happen seems weird, then that's not a reason to reject it, because the future always seems weird.
Cool. So given that we've kind of painted so far other than the kind of weirdness of the situation, we painted quite a nice view on what could happen or what is, positive within this area. And you spend a lot of time thinking about these kind of terms, which I'm going to throw out because I would like to get kind of consolidation of things like AI safety, AI alignment, the specification problem, the control problem. And it'd be really nice if you could give me an overview kind of this area and in what way are these things similar or equivalent or not at all?
Right. Okay, that's actually a really, really hard problem because there is not really widespread agreement on all of the terms. Various people are using the same terms in different ways. So broadly speaking, AI safety is like, I consider AI safety to be a very broad category that's just about like the ways in which AI systems might cause problems or be dangerous and what we can do to prevent or mitigate that. And I would call that, like by analogy, I would say if there was something like nuclear safety. And that runs the gamut. You've got like, if you work in a lab with nuclear material, how are you going to be safe and like just avoid getting long-term radiation poisoning, a la like Marie Curie? But then you have things like kind of accidents that can happen, things like the Demon Core. During the Manhattan Project, they had this terrible accident that was like an extremely unsafe experiment that dumped a huge amount of radiation out very quickly and killed a lot of researchers, which is like a different class of thing from the like long-term exposure risks. But then you also have things like in some of the applications, like if you have a power plant, there's a risk that that could melt down, and that's like one type of risk. But there's also the problems associated with disposing of nuclear waste. And like, how does that work? And then beyond that, you have all of the questions of nuclear weapons, and how do you defend against them? How do you avoid proliferation? And these types of broader questions. And so like AI safety is kind of like that, I think, in that it covers this whole range of things that includes your kind of everyday things like, are we going to have like invasions of privacy? Are these things going to be fair from like a race, gender, and so on perspective? And then like things like, you know, is my self-driving car going to drive safely? How is it going to make its decisions? Who is legally responsible? All of those kinds of questions are like kind of still under the umbrella of AI safety. But the stuff that I'm most interested in is, well, actually, let me divide up safety into sort of four quadrants along two axes, right? You have like near and long term, and you have accident and misuse. So in your near-term accident is going to be things like, you know, are self-driving cars safe or whatever. Your near-term misuse is like, how are corporations using our data and that kind of thing. And then your long-term misuse, I actually think right now is not really an issue. So when you say short-term and long-term, you could also think of that as narrow and general. I'm most interested in the long-term accident risk because I think that our current understanding is such that it almost doesn't matter like getting the right people to have AGI or like what they try and get the AGI to do. I think that currently our understanding of AGI is such that we couldn't control it anyway. And so it sort of doesn't matter. Just like getting powerful AGI systems to do what anyone wants them to do is the main thing that I'm interested in. So that's the subpart. Let's do some other terms. The control problem is a slightly older term, I think, that's about if you have an AGI, how do you control it, right? How do you keep it under control? And I don't really like that framing because it suggests that that's possible. Like, it suggests that if you have a superintelligence which like doesn't fundamentally want what humans want, that there might be some way to control it. And that feels like just a losing strategy to me. So I prefer to think of it as the alignment problem, which is how do you ensure that any system you build, its goals are aligned with your goals or the goals of humanity. So that then it sort of doesn't need to be controlled because it actually wants to help. And so you don't control it, you just like express your preferences to it. And that's not, it's like, it's only a very slight shift in framing, but I think it changes the way you think about the problem.
Yeah. And is that because I've done a bit of reading here, and it seems intractable that one can control a system which is, well, we say super intelligent, but is vastly more intelligent than we are, given we are the baseline for this kind of framing of intelligence. So on like a general person's intelligence, it's going to be much, much more intelligent than that. It can do things which implies that we won't actually be able to control it. And like you're saying, like it doesn't really matter who creates such a thing, because they themselves won't be intelligent enough, or we don't have the practical tools to contain such a thing.
Right. And like this doesn't need to be a really strong claim, actually. Like you could try and make the claim that if the thing is drastically super intelligent, then it's impossible to control it. I would prefer to make the claim that if the thing is super intelligent at all, or even without needing that claim, to just say like, this seems really hard and it would be nice to not have to try. Like it's not so much we can be certain that we won't be able to control it, but like we really can't be certain that we would be able to control it. And we do want a high level of confidence for this kind of thing because the stakes are very high. Like any approach that relies on us containing or outwitting an AGI, it's not guaranteed to fail, but it's so far from guaranteed to succeed that I'm not interested in that approach.
So I find this quite interesting because there's kind of like an implicit thing going on here in all of this stuff this AGI system has something that it wants to optimize, and it's going to do it in a runaway sort of way, or it has some sort of survival thing inbuilt into it. And whether that's to do with some sort of concept of consciousness or not, it doesn't really matter. But it has this drive all of its own, because otherwise it would be just idle, right? We're kind of conflating intelligence with some sort of thing like survival or some sort of optimization problem that we've started out on. Is there kind of like some way of coalescing these sorts of ideas?
Yeah. So the concept is agency. Right? The thing is, if we build an agent, and this is like a common type of AI system that we build right now, usually we build them for playing games, but you can have agents in all kinds of contexts. And an agent is just a thing that has a goal and it chooses its actions to further that goal. Simplest example of an agent, something like a thermostat, calling it like modeling it as an agent is kind of pointless because you can just model it as a physical or electronic system and get the same understanding, but it's like the simplest thing where the idea applies. You can think of a thermostat as having a goal to have the room at a particular temperature, and it has actions like turning on the heating, turning on the air conditioning, whatever. And it's trying to achieve this goal, and if you perturb that system, it will try and, well, it will fight you in a sense, right? If you try and make the room warmer than it should be, it will turn on the air conditioner. Or something that makes more sense to talk about as an agent is something like a chess AI, right? It has a goal of like, if it's playing white, the goal is for the black king to be in checkmate rather, and it chooses its actions in the form of moves on the board in order to achieve that goal, right?
Yep.
So a lot of problems in the real world are kind of best modeled as this type of problem, that you have an agent, you have a goal in the world, some utility function or something like that, that you're choosing your actions, which is like maybe sending packets across a network or sending motor controls to some form of actuator, whatever, and you're choosing which actions to send in order to achieve a particular goal. And like, once you have that framework in place, which is the dominant framework for thinking about this kind of thing right now, well, you then have a lot of problems. Mostly being that you have to get the right goal, right? This is the alignment thing. You have to make sure that the thing it's trying to achieve is the thing that you want it to achieve, because if it's smarter than you, it's probably going to achieve it.
Yeah, so you have to be very, very sure that goal is well specified, and that's part of this kind of specification thing, or whether that is even possible. Is it even possible to say a well-formed goal which doesn't have the potential to be, manipulated or kind of
Yeah.
interpreted in different ways?
Yeah. The thing is, it's like, what's the? It's more. This is the specification problem, right? It's not so much that the goal is going to be manipulated, as that the thing you said is not the thing you meant. That anything that we know how to specify really well is something which, if actually maximized, would not be what we want. And you can take your really obvious things like human happiness. Maybe we could specify human happiness, but like the world in which humans are the most happy is probably not actually the world that we want. Because, plausibly that looks like us all hooked up to like a heroin drip, or like some kind of experience machine that's hooking up directly to our brains, giving us the maximally happy, experience, or something like that, right? Like
Yep.
you take something which is like locally a good thing to optimize for, but once you optimize hard for that, you end up somewhere you don't want to be. This is a variation on Goodhart's law, that when a measure becomes a target, it stops being a good measure. And it's like that taken to the extremes.
So, given all this stuff, is there a sense that there is a winning direction, or is there something that is kind of like, this is the best option for alignment at the moment? The way that we can, if we had an AGI here today, that we would probably try first?
Yeah, there are a few different approaches, and nothing right now is ready, I wouldn't say, but there are some very promising ideas. So first off, almost everyone has agreed that like putting the goal in and then hitting go is like not a winning strategy. You need, firstly, because the human values are very complicated, anything that you could simply specify is probably not going to capture the complexity and variety of what humans care about. And usually the way that we do that in machine learning, when we have like a complex fuzzy thing that we don't know how to specify, is we learn that thing from data. So that's one thing, like value learning, effectively. How do you get an AI system that learns what humans care about? This is hard because value, we have these various approaches for learning what an agent cares about, but they tend to make fairly strong assumptions about the agent. Like you could, you observe what the agent does, and then you say, well, what does it look like they were trying to do? What were they trying to achieve when they were doing all this? And this works best when the agent is rational, because then you can just say, well, suppose a person were trying to achieve this, what would they do? And then, well, did they do that? Whereas humans have this problem where we like sometimes make mistakes. We sometimes choose actions which aren't the best action for our goals. And so then you have this problem of separating out, like, does this person really value like doing this weird trick where they fly off the bike and land on their face? Or were they not trying to do that?
Yeah. Is there like sorry to interject, is there like a category of things where this isn't the case? So if we worked on problems which weren't like innately human, so if the goal was set to understand the weather patterns enough, this is already getting badly described, but your goal, okay, Rob 3000, is to predict the weather for accurately tomorrow. Go, and you would have, that would be the thing to optimize for. That seems to me like something that doesn't actually have so much human involvement in there, or is it going to trickle in somehow anyway?
But also that feels like it doesn't, like you can do that very well with a narrow system. You don't really need AGI for that task. And if you set AGI that task, then, well, that's apocalyptic, probably, in a few different ways. Firstly, because you can do that job better if you have more sensors, and so any square inch of the planet that isn't sensors is kind of a waste from that agent's perspective, if that's its only goal. Secondly, humans are very unpredictable, so if it's optimizing in a more long-term way, if it's myopic and it's only trying to do tomorrow at any given time, you might be okay. But if it cares about its long-term aggregated rewards, then making the weather more predictable becomes something that it wants to do. And that's not good for us either.
So I feel like that leads into kind of these other ideas I was going to ask about. If you'd seen the Human Compatible by the eminent Dr. Stuart Russell, and he has this idea about ambiguity, right? So you don't necessarily have optimize the weather, no, not optimize the weather, but tell me what the weather's going to be like tomorrow, but don't harm humans, and also don't, it doesn't have this hierarchy of things to fulfill. It has this kind of ambiguity towards a given goal, which it's constantly checking for. So it's the feedback is never going to get 100% accurate, and it's always going to need to ask questions. And like you were saying, it's going to it's constantly kind of have to reaffirm its model of the world, and with humans in it, essentially, I guess. What are the things that humans want to do?
Yeah. So this is like a much more promising family of approaches where you don't try and just learn. You don't just learn up front. Oh, right. The first thing that doesn't work is specifying the goal up front, right? So then, okay, maybe we can learn it. Maybe we can look at a bunch of human data and then learn what the goal should be and then go. And that also has problems because even if it's kind of brittle. If you get it slightly wrong, you can have giant problems. And also you have a huge distribution shift problem where if you train the system on everything you know about humans right now, and then you have a world with an AGI in it, and that's like quite a different world. The world starts changing, and so then you have this classic problem that you always have in machine learning when the deployment distribution is different from the training distribution. So some kind of online thing seems necessary where the system is continually learning from humans what it should be doing. And yeah, so there's a whole bunch of approaches in this like category. And yeah, having the system start off completely uncertain what its goal should be, but just knowing that its goal is in the minds of the humans and is and that the actions of the humans are information, are data that gives it information about its actual goal, seems fairly promising. Yeah.
Cool. I like it. I felt like when I was reading that, it had this really great bit, which was, and I'm sure it will be all kind of ethical. We'll just work that bit out. There's like, because obviously this is the stuff that I care about. The fact that these things are uncertain doesn't imply that it will be, a ethical AI or AGI. Because obviously you're learning from people, and people can be have a spectrum of values, and they can do stupid things that hurt people or put people at disadvantage. So I think it's when I was looking at that specific example, it's interesting that it is sort of solves this runaway kind of optimization issue, but it doesn't necessarily solve that the agent will actually do stuff which is in people's general benefit, but it might do stuff which is in a person's general benefit, possibly. There's these other issues, I guess, that come up.
Yeah, totally. So this is like another way of splitting the question, which is, are you for the alignment problem? The general form of the alignment problem is you have a single artificial agent and a single human agent, and it's just like a straightforward principal agent problem. You're trying to get the artificial agent to be aligned with the human agent. This is hard. In reality, what we have is we might have a single artificial agent trying to be aligned with a multitude of human agents, and that's much harder. You can model humanity as a whole as a single agent if you want, but then that kind of introduces some problems, obviously. And you might also have multiple artificial agents. And that depends on what you think about like takeoff speeds and things like that, like how you model the future going. I assign a fairly high probability to there being like one artificial agent which is so far ahead of everything else, becomes so far ahead of everything else, that it has like a decisive strategic advantage, and the other ones, whatever else there is, kind of doesn't matter that much, and so you're really aligning one to many. But that's by no means certain. We could definitely have a situation where there are a bunch of artificial agents that are all interacting with each other as well as with humanity, and then the whole thing gets much more complicated. The reason that I am most interested in focusing on the one-to-one case is because I consider it not solved, and I think it might be strictly more it might be strictly easier. So like I find it hard to imagine, and I don't know, I mean, like, let's not be limited by my imagination, but I find it hard to imagine a situation where we can solve one-to-many without having first solved one-to-one. If you can't figure out the values of a human in the room with you, then you probably can't figure out the values of humanity as a whole. Probably. That just feels like a harder problem. So it's not like I'm aware that solving this problem doesn't solve the whole thing, but I think it's like a necessary first step.
Yeah, you're not skulking away from the bigger issues here, Rob. Come on, you just sort it out.
Yeah. Well, I mean, it's there's no reason to expect it to be easy, right?
No, definitely not. And I don't think, I mean, there's a lot of stuff in this area where there isn't necessarily consensus, and it's still very much a
Absolutely
burgeoning area where I think someone said that there's just simply not enough people working in this area at the moment.
Yes, the density, like the area of space. If you look at something like computer vision or something like that, you look at one researcher in computer vision and what they're working on, and it's a tiny area of the space, right? And they are the world expert on like this type of algorithm applied to this type of problem. Or like this type of tweak or optimization to this type of algorithm on this type of problem. Whereas what we have in AI safety is researchers who have these like giant swathes of area to think about, because there are not enough people, and like there aren't even enough, like AI safety as a research field, or AI alignment, is divided up into these various sort of camps and approaches, and a lot of these approaches are entire fields that have like 2 people in them, you know?
Yeah.
Because it's just like the person who first thought up this idea, and then somebody else who's like has an interesting criticism of it, and they're debating with each other or something like that. And like that's the thing. And in 5-10 years, that's going to be a field full of people, because there's easily enough work to do there. It really is like a wide opening frontier of research.
Awesome.
So if you're interested in doing
yeah, exactly. the plug.
No, if you genuinely, if you want to make a difference in AI research, you want to have a big impact, both in terms of like academically, but like if you want to make a big impact on the world, this is like probably I don't know what even is second place. Anti-aging research, maybe, but it's definitely up there as the best thing to be working on.
So does consciousness and this idea of the superintelligence maybe being intelligent in a way that we could ascribe consciousness to it, all about the ideas that we have around consciousness may apply, does that come into this equation of alignment, or the idea of the superintelligence?
Yeah, for me it doesn't. because I kind of feel like I have no need of that hypothesis. Like, at least in the abstract, you can model something as a utility maximizer, and then it's just like a straightforward machine. It's building this model of the world. It can use the model to make predictions. It has some evaluation utility function that it can look at possible world states and decide how much it wants those. And then it can look at its actions and make predictions about what would happen in the case of each action. And it chooses the action which it thinks will lead it towards a world that scores highly according to its utility function. And like, at no point in this process is there any need for like internality or consciousness or anything of that grander scale. It's possible that like in practice, when you build something which does this, it ends up with that somehow, maybe?
Yeah.
I don't know. But it doesn't seem necessary. It doesn't seem like a critical consideration, I think.
It's not a component that is implied by whatever the outcome is of the system.
Yeah. And the other thing is that if we have a choice, I think we should try to make systems that aren't conscious, if that's an option, because I would rather not have to worry about... There's all kinds of problems that you have where you turn on the system and you realize that it's not quite doing what it should, and now is it ethical to turn it off and all of that kind of thing. Like, considering that consciousness doesn't seem to be necessary for capability, which is what we care about, if we can avoid it, I think we actually should.
Yeah, that's really interesting. I'm just trying to think of ways that it would be advantageous to choose consciousness, but I guess then we're getting into the power of kind of, Dr. Frankenstein situations where you are making a decision over and above the actual reality of the situation as a need, as a requirement. So, yeah. There's a certain amount of hubris there, Rob. That's the word I was looking for. Hubris.
Well, yeah. I mean, it's not the hubris is implicit in the overall project, right? You're trying to create a thing that can do what human minds can do. That's inherently hubristic, and again, I'm kind of okay with that. Seems unavoidable.
So, given the long-term kind of scope of this, is there something that is there some kind of really interesting stuff that's coming through right now? I mean, I've literally just read a paper yesterday about the halting problem, and that's because I was trying to prepare for this and dive into something somewhere, other than your brilliant videos. So is there anything else that you want to really kind of bring to the fore about what is exciting you in this area at the moment?
I mean, there's all of these approaches that we didn't talk about. That, like, I feel like you had a question that was about this that we didn't actually get into, where we could talk about. But there's too many of them, and I don't want to go into detail about them because, well, I probably would get it wrong because I haven't actually I haven't read the papers about this recently. But you talked about Stuart Russell stuff, but the stuff that's happening at OpenAI is interesting as well. Things about AI safety via debate, things about iterated amplification are really interesting. And the stuff at DeepMind, like recursive reward modeling and that kind of thing, which I'm going to have a video about, hopefully, sometime soon. But these are kind of people thinking about how we can take the types of machine learning stuff we have now and build AGI from it in a way which is safe. Because people are thinking quite strategically about this. The thing is, it's no good coming up with something that's safe if it's not competitive, right? If you come up with some system that's like, oh yeah, we could build an AGI this way, and it would almost certainly be safe, but it's going to require twice as much compute power as doing approximately the same thing but without the safety component. It's very difficult to be confident that nobody else is going to just do the unsafe thing first. So like fundamentally, as a field, it's kind of difficult. We have to tackle this. What am I saying? Like as a field, it's pretty difficult. We have to solve this on hard mode before anybody else solves it on easy mode. So people are looking at trying to be the first people to create AGI and having that be safe as like a joined problem. And those types of things seem pretty promising to me.
And it's solving the problem of, like you're saying, someone else creating it, which isn't safe, right? So you're trying to get there before they get there with the more correct option, or a better aligned option.
Yeah. So that's another thing that's like, if you're not like technically minded, if you're not well placed to do technical research, there's a lot of interesting work to be done on governance and policy as well. And that, like, AI governance and AI policy are also really interesting areas of research, which is like, practically speaking, how do you steer the world into a place where it's actually possible for these technical solutions to be found and to be the thing that ends up actually being implemented in practice? How do you shape the incentives, the regulations, the like agreements between companies, between countries? How do we avoid this situation where we all know that whoever makes AGI first controls the world, or we think we know that, and so then everybody's just going as fast as they possibly can, and you end up with like an arms race, like a space race type situation, in which people are obviously going to be neglecting safety because safety slows you down, and then you end up with nobody winning. How do you get people to understand? This is like a much broader thing. How do you get people to understand that there are positive sum games? That like zero sum games are actually pretty rare, and that it's so much better to get like 1% of a post-singularity utopia perfect world than 100% of an apocalypse. Like, that we have so much to gain through cooperation. So like unimaginably vast amounts of value to be gained through cooperation, and like a really good chance of losing everything through not cooperating, or like a bunch of outcomes that are like dramatically worse than losing everything are actually in play if we screw this up. And just getting people to like, can we just slow down and be careful and do this right? Because like this is really we are kind of at the hinge of history. This is the point where like this next century is where we win or we blow it completely, right? I don't see an end to this century that looks approximately like what we have now, right? This is the point. This is for all the marbles. And like, can we pay attention, please?
Yeah. And I think that argument can almost be applied to lots of different areas, right? Like the environment, biodiversity, maybe ideas around poverty and equality and things like that.
Yeah. The thing is, and this is like, do you want to talk about hubris? Like, I would be a lot more concerned about things like climate change. Like if I didn't know the things that I know about AI, I probably would be focusing on climate change. But climate change is fundamentally not that hard a problem if you have a superintelligence, right? Like if you have a system that's able to figure out everything that we, if you have this kind of sci-fi situation, then just being like, oh, the balance of gases in the atmosphere is not how we want it, and the thing's figured out like molecular nanotechnology or something, then potentially that problem is like just one that we can straightforwardly solve.
Yep.
You just need something for pulling out a bunch of CO2 from the atmosphere and like whatever else you need. I don't know. I'm not a climate scientist, but like, and likewise poverty, right? If you get something which is aligned with humanity, not aligned with like whoever happens to be running it, then I don't anticipate poverty. Possibly there would be inequality, right? In that some people would be like drastically richer than the richest people today, and some other people would be like 5 drastically richer than the people today. But like, I'm not as concerned with inequality as I'm concerned with poverty. I think it's more important that everybody has what they need than that everybody's the same. That's a personal political position. But and again, it's that kind of thing, right? Like, if the problem is resources, if the problem is wealth, then solving intelligence, it's not like a open and shut thing, but like you're in such a better position for solving these really hard problems if you have AGI on your side. And so that's why I kind of, with my choices in my career at least, I'm putting my eggs in that basket. I don't think that everyone should do that. I'm glad that there are people working on the more sort of, the things we can be more confident will definitely actually pay off. But I do see AGI as kind of a Hail Mary that we could potentially pull off, and it's totally worth pushing for.
Yeah, I think it's one of those things where we are confident now that things are going badly, so we should sort that out. But with the AGI stuff, it could go really well, but we shouldn't die before we get there, right? We should probably sustain and be good to the world before we fuck it all up, and then we haven't got this opportunity to then go on to do these other,
absolutely
solutions.
Yeah, I don't advocate neglecting these problems because AGI is just going to fix it at some point in the future, all or nothing. But it does, like, there is an argument that working on this stuff is actually a reasonably, like, there's a line through which solving this solves those problems as well, and that increases the value of this area, I think.
Yeah. So the last question we ask on the podcast is to do with what really excites you and what really scares you about this kind of technologically advanced autonomous future. But I guess we kind of spoke about this apocalypse and possible, not necessarily utopia, but being able to leverage
relative utopia.
Yeah, relatively utopia. So does that cover it, or are there other things that strike you?
Yeah, it's a funny question, isn't it? It's like, apart from the biggest possible negative thing and the biggest possible positive thing, how do you feel about this? Yeah, no, I think it covers it.
Yeah, okay. Sorry, I thought that might be the case. I just thought I'll give you the opportunity anyway.
Yeah, no, totally.
So thank you so much for your time, Rob. I feel like it's one of those things that we could definitely mull this over for the rest of the day. And I'm gonna let you go now. But could you let people know how they can follow you, find your stuff, and get hold of you and that sort of thing?
Yeah. So I'm Robert S.K. Miles on most things. Twitter, Reddit, Gmail, whatever. That's SK. And the main thing is the YouTube channel, I guess, which is Rob Miles AI. I also make videos for the Computer File channel, which is computer file with a PH, like a person who loves computers. And if you're interested in the technical side, like if you're a researcher, particularly, not necessarily a safety researcher, but if you're interested in machine learning or just have any kind of computer science background, really, I would really recommend the Alignment Newsletter podcast, which, or just get the Alignment Newsletter in your email inbox. But if you prefer listening to audio, which you might on account of how you currently are, Alignment Newsletter podcast. It's a weekly podcast about the latest research in AI alignment. And I think that's it for me. Yeah.
Cool. Well, thank you again so much, and I'm definitely gonna have to have yourself or someone else back so that we can mull over some of this again. But really, really interesting, exciting. So thank you.
Nice, thank you.
Hi, and welcome to the end of the podcast. Thanks again to Rob. He's someone I've been following for a couple of years now, his stuff on Computer File and also his own output. So it's really amazing that I get to talk to people like Rob and other people I've talked to in the past on the Machine Ethics podcast about some of these questions that have just been itching inside of me to ask as I've been watching their work or reading their work. So it's really fantastic I was able to get hold of Rob. One of the things in our conversation is that I wasn't quite as determined or as certain as Rob was with achieving AGI, but I admire his devotion to the fact that, if we do, then we should probably do it with good outcomes. This podcast was kind of a continuation from our interview with Rohin Shah, so if you want to listen to more in this vein, then go and check out that episode and find more episodes on the podcast. And thanks again, and I'll see you next time.